Hello class, this is the lecture on the heat transfer experiment data analysis. You should know how to perform this analysis for something like the final. So the first thing I asked was for you to plot the four thermocouples. Just plot their heating curve, and here it is, different color for each thermocouple, and we use symbols because these are data points, right? This is experimental data. Looks like a line because the data points are so close together, but you can tell they're symbols by the legend. Here's the cooling curve for thermocouple 1. Similar comments apply. And you are also asked to tabulate your data. So here's an example of a good good table rather. Captions on the top. Everything's left justified. Units are included. So you were asked to solve for the thermal conductivity of copper using the experimental data. And this is the governing equation. This is the heat conduction equation. It's saying that the heat transfer, that's in watts, is Q dot. It's equal to minus times the coefficient of conductivity times the cross-sectional area times dt over dx. And this dt over dx is the temperature versus distance curve. Solve out for Q, and you come up with this equation here. And the question is, where do you get dt dx from? Well, some of you just took the first data point and the last data point and subtracted. That's not the best way to do it. The best way is to plot the 4 points. So this is temperature on this vertical axis, distance on the horizontal axis, then fit a best fit trend line, fit a linear trend line to the data. Plot out the equation, and this y, this slope of this line in this equation, minus 254.3, is dt over dx. The next thing you were asked to do is to solve for the time constant for one of the thermocouples cooling curve. And this is the governing equation at the top. We're looking for tau. So the thing to do is to solve this equation for tau. And you get this final equation down here. And then you're supposed to plot t minus t naught on the y-axis and then minus the log of these temperature differentials on the x-axis. And you get something like this. And the slope of this line would be tau. So it's about 315 is tau. And that would be in seconds. And then the last thing you were asked was to plot the experimental data versus the predicted value. And here you can see quite a good match. Theoretical data is plotted with straight lines, no symbols, not straight lines, just lines, right? It could be dotted, dot dash, whatever. But just make sure there are no symbols, and experimental data is always plotted with just the symbols and no lines. Okay, that's it. See you in cyberspace.